What is complex number? A number is of the form x plus iy. X plus iy is called a complex number where I is equal to root over of minus 1 and xy belongs to R. Set of real numbers. A number is of the form x plus iy is called a complex number where I equal to root over of minus 1 and xy belongs to R. X is called real part of z and y is called as imaginary part of z. X is called real z and y is called imaginary z. Remember one thing, if x equal to 0, then the complex number is called purely imaginary. If y equal to 0, is called purely imaginary. If y equal to 0, then the complex number is called purely real. Understand? Again, if C is not the set of complex number and is defined as C equal to C Z, so that Z equal to x plus iy where I equal to root over of minus 1 xy belongs to R. Set of real numbers. This is the complex number, set of complex number, and you denote that C, and C is called set of complex number and it is defined as Z equal to Z such that Z equal to x plus I where I equal to root over of minus 1 and xy belongs to R. A complex number is also written as ordered pairs. That is, if you write any complex number as ordered pairs AB, Z equal to AB, then here A is the real Z and B is the imaginary Z. Understand? You take some examples that you have to consider some examples and you have to mention what is the real Z and what is the imaginary Z. Okay. So take some examples. Root 2 plus I, root 2 plus 3i, root 5, 0. Then you have to 0. You have to say that the real Z and the imaginary Z. Remember, in Z equal to a plus ib, a is the real Z and b is the imaginary Z. So root 2 can be written as root 2 plus 0i. So here real Z is root 2 and imaginary part of Z is 0. One thing. Then you have to root 2 plus I. Here root 2 is the real Z and 1. Root 2 is the real Z and 1 imaginary Z equal to 1. Okay. And root 2 plus 3i. You have to take the example root 2 plus 3i. Here root 2 is the real Z and root 3 is the imaginary part of Z. Also, then you have to, for example, root 5. Root 5 can be written as root 5 plus 0i. And root 5 is the real Z and 0 is the imaginary part of Z. Okay. So take some other examples. 0 can be written as 0 plus 0i. And 0 is called real Z and 0 is also called imaginary part of Z. Okay. 0 is a number which is purely real and is purely imaginary. Let us go to start equality of two complex number. Equality of two complex number. Okay. So whenever you have to say that two complex number are said to be equal. Two complex number are said to be equal if the real part and the imaginary part are separately equal. So consider two complex number Z1 equal to a plus ib and z2 equal to c plus id. this Z1 whenever you have to say that Z1 equal to Z2, if and only if A equal to C and B equal to D. So let us start the proof. Okay. So given that Z1 equal to Z1 equal to Z2, this will be given. If Z1 equal to Z2, that means A plus IB equal to C plus ID. So equate the compare the real part and the imaginary part. So A minus C equal to I whole into D minus B. Okay. Then the squaring on both sides. So getting the squaring, A minus C whole square, I square, D minus B whole square. And we know I square equal to minus 1. So A minus C whole square into minus 1 minus D minus B whole square. And it becomes A minus C whole square plus D minus B whole square equal to 0. We know that two non-zero squares are equal if and only if they are both equal to 0. That means whenever you have to say that x square plus y square equal to 0, if and only if it only possible if x equal to 0 and y equal to 0. That means here A minus C whole square equal to 0 and D minus B whole square equal to 0. That means A equal to C and B equal to D. This is your complete proof. So let us take some notes about this. Remember one thing, if Z equal to 0, that means x plus I equal to 0 plus I0. That implies x equal to 0 and y equal to 0. Okay. If you say that we know x plus y equal to 0, that means x equal to minus y. Okay. If you whenever say that x plus iy equal to 0, you cannot say that x equal to iy minus iy. This is correct, but this is incorrect. Okay. Equality does not hold in case of complex number. That means you cannot predict the equality condition in case of complex number. For example, you cannot say that 4 plus 3i is greater than 2 plus I, because equality does not hold in case of complex number. Okay. And you have to say that 0. This is a most important. This is 0. 0 is called as purely real and purely imaginary. Okay, 0 is also called as purely real and also called as purely imaginary. So taking some examples, I have given some examples to find out. These are the two examples. The first example is x plus iy into 2 minus 3i equal to 3 plus ii. We have to find the values of x and y. Okay, so given that x plus iy equal into 2 minus 3i equal to 3 plus i. Okay, you have to find that x plus I. So x plus iy equal to 3 plus I divided 2 minus 3i. You have to simply multiply the conjugate on both sides. Conjugate means you have to replace I in place of minus I. Sorry, you have to replace in place of I to minus I. So you have to replace I to minus I. So 2 plus 3i into 2 plus 3i. That means it becomes 6 3 plus I. So it becomes multiply the on both sides. So you get to 6 plus 9i plus 2i. It becomes minus 3. Okay, and it becomes a plus ib into a minus ib, 2 square minus 3i whole square. So it becomes 6 minus 3, which is equal to 3, 9 plus 2i, which is equal to 11i divided by, it becomes 4 plus 9 and it becomes 13. 3 plus 11i divided by 13 and it becomes 3 plus 13 is 11 by 13. That means x equal to 3 by 13 and y equal to 11 by 13.